So folks, here I've put in the address of our wonderful Front Range Community College, and you can see we've got the map of Colorado, and it's put a little pin at that location, and we can zoom in on this. Here we're getting to see the Denver metro area. We zoom in a little more, we're starting to see Westminster, well, Broomfield anyway, maybe we can see Westminster. We keep zooming in. Here's our here's the big open space behind Front Range, and we keep zooming in. And here we can see Front Range Community College in pretty good detail. By the way, our math class is about right here, and the math center where you can get some help is right about over here. But what I actually want to look at is the way of representing these coordinates. And it turns out that similar to the way we work with labeling coordinates on a circle with degrees, we can also use similar degrees, if you will, for longitude and latitude to talk about locations on a sphere. And I don't really want to get into that discussion, but what I do want to point out is that if I look over here, you can see that I've got the longitude and latitude, and these are both measured in degrees here. Okay, they're measured in decimal degrees. And so we've got the longitude for Front Range Community College is minus 105 degrees. Put another way, we're at 105 degrees west for our longitude. And our latitude is 39.9 degrees, and that would be 39.9 degrees north. And you can see we're very accurate with this, or at least it appears to be accurate because of the number of decimal places we have. But what I want to talk about is this other way of representing a location in terms of degrees, minutes, and seconds. So notice this is a latitude of 39 degrees. It still has a latitude of 39 degrees, but rather than saying 0.901 decimal of a degree, we have 54, and this symbol we're going to show means minutes, and then 5.742, and then we're going to show that this symbol is going to stand for seconds. Likewise, instead of saying that we're at a longitude of minus 105 degrees, first of all, we're going to be 105 degrees west. That won't be what we get into in this class. But what I want to talk about is the decimal degrees. Rather than saying decimal 037 degrees, we're going to say that's 2 minutes followed by an additional 15 seconds. What we want to do in this pre-work is learn how to convert back and forth between working with these two different ways of subdividing degrees. My guess is that writing decimals of degrees makes sense, and we'll look at that. And this will be a little bit more challenging to think about degrees this way. Our pre-work will explore this, so I'll see you there. Okay, so let's step back a little bit, folks, and look at how we've talked about dividing up a circle. So we have this intuitive notion that we want to talk about opening up an angle. You know, we might have just some random angle here that's in standard position, and we want to talk about how to measure this angle. And we've talked about how we could measure it in terms of radians. What I would do is I would break this up into a little bit more than 6 segments. There's one segment, there's 2 segments, there's 3 segments. Let's make that just a little bit closer. There's 3 segments. Remember that pi segments would be 3.14 of those. And then we have there's 4 segments, 5 segments, 6 segments, and so 6.28 segments. So we've broken this up into segments that we called radians. Okay, and we'll be studying that quite a bit more. What I want to look at instead is this alternate way we've talked about dividing up a circle, where we've said that we could say this is 0 degrees, which is the same as 360 degrees, and over here we have 180 degrees. This would be 90 degrees, and I think intuitively, if I told you I asked you where is, say, 27 degrees, you would guess that maybe right about there is 27 degrees. Okay, so what we want to do now is we want to look at fractions of a degree, and we've got a few ways we could do this, and I'm going to exaggerate this immensely, and I want us to look at this angle right here. Oops, that's supposed to be in blue. Let's try that again. I want to look at this angle right here, and I'm going to tell you that this angle is 1 degree on some massive circle that we're looking at. So let's put that in red. Some massive circle that we're looking at. And so what we're looking for in this section is how could we break up parts of a degree. And I think that you would agree that, if this is 1 degree, this angle right here, this has been largely exaggerated, but if we were to take half that distance, then that should be the 0.5 degrees. I think we'd all agree with that. And then maybe we could break this up into 5 equal segments, and so this would be a fraction 0.1 degree. So I think we have, just having worked with decimals in the real world, we have this intuitive notion of how we could deal with decimal degrees. What we want to do is also introduce this notion of degrees, minutes, seconds. To help us feel a little bit better about this, I actually want to do a problem in terms of distances, which we're a little bit more comfortable with. Here I've got a distance of 1.20437 miles, and I want you to contrast that with the distance 1 mile, 1,079 feet, 3 inches. Now you might guess this, and you'd be right. These are actually the same distances. And nobody feels very bothered by this. The fact that 1.2 miles is about 1 mile and then another, about 1,100 feet. That these two distances are the same. It's just that here we're dealing with fractions of a mile, or decimals of a mile, 1.20437. Those are in decimals of a mile. And here we take out 1 whole mile, but then we subdivide the fraction of a mile into new units. In this case, the new units that we subdivide the mile into are feet. And then we take whatever feet we have left over, if we don't have a whole foot, and we subdivide the foot further into this smaller quantity of measurement called inches. So that's supposed to be sort of our connection in what we're doing here. So let me just point this out. How would I get from this statement to this statement? Well, we know that this is 1 mile plus 1,079 feet plus 3 inches. Now, copying down the 1 mile part and the 1,079 feet part, I'm going to rewrite this in terms of inches, yes, but I'll say that's 3 inches out of 12. And so now this is back in terms of feet, because we have 3 inches was equivalent, or 1 foot is equivalent to 12 inches. And so now we're in the units of feet. So now that we could think of this as 1 mile plus 1,079.25. How did I get 0.25? Because if I actually take 3 divided by 12, you check this, you get the decimal 0.25. And so we've got 1 mile plus 1,079.25 feet. Finally, we could say, well, that's 1 mile plus, and then we know that that would be 1,079.25 feet divided by the 5,280 feet that are in a mile. And if we then combine these together, this comes out to be, and you can confirm this, the 1.20437 miles that I said it would come out to be. Okay, so hopefully that gives you a little bit of a sense of how we compare, the decimal mile to this mile, and then its subparts are written in new units. We're going to do the exact same thing with degrees, and this is not going to be, an essential topic of this course, but really you shouldn't get through a trigonometry class without seeing degrees, minutes, seconds. And I'm not going to do this all the time, but it will be good practice, especially because, as we saw in that first video, we often have to deal with degrees, minutes, seconds in the real world with longitude and latitude. So for anyone going into GIS backgrounds, you will need this knowledge of degrees, minutes, seconds. So let's get started. It's customary to sometimes subdivide degrees into a new unit called minutes, where each minute is 1/60th of a degree. And we're going to use this symbol right here, minute. That looks like, just like we had the symbol for feet, is that apostrophe there? It looks like that for minutes. Okay. So let's put that another way. Let's say so we said that each minute is 1/60th the degree. Another way to say that is there are 60 minutes in 1 degree. Now, this is not the minute as in the increment of time, although we go ahead and use the same unit factor. That is, we've got 60 minutes in a degree, just as and those are measurements of an angle. just as there are 60 minutes in 1 hour. So we're using that the same way. And then it's nice to then subdivide minutes. So we've got minutes, and we subdivide minutes into seconds, where each second is also 1/60th, but now it's 1/60th of a minute. Excuse me, I have an error here, where each second is 1/60th of a minute. I'll get that fixed for your notes, folks. So we're going to use this symbol for seconds. And that should fit with maybe how you've used increments of time. It also works for these degrees. It's also how we do feet and inches. Okay, so here we go. These are the problems I want us to be able to work. So let's go ahead and convert 74 degrees, 8 minutes, 14 seconds into decimal degrees rounded to the nearest thousandth. Okay? So one more time, we would read this, and you should practice reading this aloud. This is 74 degrees, 8 minutes, 14 seconds. And we want to convert that back into decimal degrees. So we would say that that's equal to 74 degrees plus 0.8 minutes plus 14 seconds. Let me get my minute sign going the right way. And just like I did before here, I could write this as 74 degrees plus 0.8 over 60 degrees. And then just if you're interested, there's a way I could explain this. I think I'd rather just show you that if there are 60 seconds is equal to 1 minute, and then there are 60 minutes is equal to 1 degree, I think you can see then that there are 3,600 seconds equal to 1 degree. And so I'm going to add to this 14 divided by 3,600. If you'd like more of an explanation of this, if you find this challenging, please come by and see me, and I'd be happy to explain that in more detail. What this now enables me to do is to write each one of these as a in terms of degrees, and so this will be fractional parts of degrees. And so I'll go ahead and just actually, I'm going to plug this into a calculator and get just a single. So I went ahead and plugged this into my handy dandy Desmos calculator. We've got 74 degrees plus the 8 minutes per 60 degrees. So we have 8 minutes, so that's that fractional part, plus the 14 seconds divided by the fact that there are 3,600 seconds in a degree. So these are now all in degree form. When I add them together, we end up with 74.1372, and I think I asked you to round this to the nearest thousandth, so we'll call it 74.137. So we ended up with 74.137 degrees. So now we want to convert this particular decimal degree into degrees, minutes, seconds. And this is the part that's a little bit harder here. So let's take a look at it. So there's probably several ways to explain this, folks. What I'd like to do is this. I'm going to write our original problem, 34.817 degrees, and I'm going to write that as 34 degrees plus 0.817 degrees. Then I'm going to multiply this by its appropriate conversion factor. And like I said, there's other ways to explain this. If you have questions about it, come by and see me. But the conversion factor that we would use is that there are 60 minutes per 1 degree. And if I go ahead and crunch this, what I end up with is 34 degrees plus, and then when I crunch this, I did it beforehand, we ended up with 49.02 minutes. By doing this, when I multiplied 0.817 degrees by my conversion factor, that converts me into minutes. And so roughly you could say is roughly 0.81 degrees is roughly 49 minutes. Okay? Now what we need to do is we need to be in degrees, minutes, seconds. So I need to subdivide. This is my fractional part of a minute. I'm going to peel that away. So this gives me 34 degrees plus 49 minutes plus an additional 0.02 minutes. And now I'm going to multiply it by its conversion factor. And the conversion factor for converting from minutes into seconds is the fact that there are 60 seconds per 1 minute. And if I did that multiplication, which again I did beforehand, on a calculator, you'll need a calculator for this, we get 34 degrees plus 49 minutes plus 1.2 seconds. When I do 0.02 minutes times the fact that there are 60 seconds per minute, that's what I end up with. And then it's customary not to write that plus sign. We just write it this way. And now this looks like similar to the coordinates that you might see in a GPS system. So there we've done that conversion. Okay, so let's look at this last problem here. This is this almost feels like a throwback to something you might have done in earlier grade schools. But I'm going to go ahead and take 90 degrees and subtract from it 73 degrees 12 minutes. And so we write 90 degrees, and we're going to go ahead and say minus 73 degrees 12 minutes. And that reminds me of, well, if I had some fractional degrees here, I might be able to simplify this. So I'm going to do something that, I don't know, in elementary school I called it borrowing. You might have learned it differently, but I'm going to go ahead and say that's 89 degrees plus 60 minutes. And we're going to subtract from that this 73 degrees plus 12 minutes. And so, let me fix that. And when I subtract that down, I'll be able to actually perform this operation. So as a reminder, that was that idea of borrowing. So I say, okay, 90 degrees could be thought of as 90 degrees plus one more degree, and I wrote this plus one more degree in terms of minutes. So now we can go ahead and actually do the subtraction. When we do so, let's see here, 60 minus 12, that gives me 48 minutes. And now I can perform this subtraction, no problem. We have, that would be 16 degrees. So if we were to take 90 degrees minus 73 degrees, 12 minutes, I did this notion of borrowing a degree and then subtracting. There's actually many other ways you could do this. For example, you could convert both of these into decimal degrees, then do it with the ordinary subtraction, and then convert your answer back into degrees, minutes, seconds. There's lots of ways you could do this, and this is how I've chosen to do so. All right, folks, I hope this was helpful. You'll have a couple problems with this. This is not going to be the most important thing we do in this class, but you should have seen and you should have practiced a couple times converting back and forth between degrees, minutes, seconds, and decimal degrees. All right, that's the last of this pre-work. We'll see you next time.